protocols and switch management. The spanning tree protocol. Function. This protocol prevents network loops by creating a tree-like structure within the network. It ensures a single active path between two network points, analogous to creating a family tree to clearly understand relationships. Interface configuration and switch management. Overview involves the setup of network interfaces and the administration of network switches, similar to organizing individual workstations and managing office resources. MDIX. Description. MDIX refers to a type of port on a switch that allows connection to another switch or hub without the need for a crossover cable, akin to a universal charger for various devices. Trunking. Functionality. Trunking allows traffic from multiple VLANs to move across a single link, comparable to a main road that connects several side streets. Port mirroring. Purpose. Used for sending a copy of network packets seen on one switch port to another for monitoring, similar to installing a security camera for observation. Port authentication. Security aspect. Provides a layer of security, ensuring only authorized devices can connect to the network, like bouncers checking IDs at a club entrance. Power over Ethernet PoE and PoE Plus. Capability. PoE allows electrical power to be transmitted along with data on Ethernet cables, enabling devices to be powered via the network cable, similar to phone lines carrying both voice and power. MAC address table. Rule. A list within a switch that maps devices' physical addresses to their ports, functioning like a detailed guest list at a reception. Switch management. Management tasks involves maintaining and monitoring network switches, crucial for ensuring smooth network operation, akin to overseeing a team in a workplace. Managed and unmanaged switches. Comparison. Managed switches offer greater control over the network, while unmanaged switches are simpler, plug-and-play devices, paralleling the difference between smartphones and basic phones. Quality of service QoS. Network priority. A feature that prioritizes certain types of network traffic to maintain performance, like designating fast lanes for emergency vehicles during heavy traffic. Traffic shaping. Traffic management. The practice of regulating network data transfer to optimize and ensure efficient data flow, comparable to synchronizing traffic lights for smoother traffic. Access control lists ACLs. Traffic control. ACLs are sets of rules that govern the incoming and outgoing traffic in a network, acting as gatekeepers to allow or deny traffic, much like a bouncer's role. ARP and RARP. Address translation. ARP address resolution protocol converts IP addresses into MAC addresses, while RARP reverse address resolution protocol performs the reverse process, akin to matching names to faces and vice versa. This structured overview provides insights into various aspects of network protocols and switch management, using everyday analogies to elucidate complex technical concepts. Network engineer training. In the bustling metropolis of Network City, a network engineer is akin to an urban planner and traffic manager rolled into one, Every day, they navigate the complex web of protocols and switches that keep data flowing smoothly and securely through the city's digital streets. One morning, as our engineer sips coffee, they review the network's topology. They liken the spanning tree protocol (STP) to the city's traffic lights and signs, preventing data packets from endlessly circling roundabouts and creating gridlocks. By ensuring a loop-free and efficient path through the network, STP keeps the city's data traffic flowing smoothly, much like a well-coordinated traffic system keeps cars moving efficiently through city streets. As the day progresses, the engineer turns their attention to switch management. They configure interfaces and administer switches, laying down the digital roads and pathways that connect different districts of Network City. With MDIX, connecting these switches is as seamless as snapping together modular pieces of a toy track. No need for special crossover cables or complex configurations. Then comes the task of managing trunk links, the city's highways. Just as a highway allows multiple lanes of traffic to flow between different parts of the city, trunking permits data from multiple LANs to traverse a single network link. Our engineer ensures these highways are wide and robust enough to handle the city's growing data traffic, preventing bottlenecks and ensuring a smooth commute for all data packets. Midday brings a new challenge, setting up port mirroring for security monitoring, akin to installing CCTV systems in vital city areas. This allows the engineer to observe and analyze traffic, identifying any unusual or malicious packets that might indicate a security threat, much like how security personnel monitor video feeds for suspicious activity. In the afternoon, the focus shifts to power over Ethernet PoE. Just as modern cities look to integrate power and data cables into sleek, efficient units, PoE allows the network to power devices through the same cables that carry data, reducing clutter and simplifying infrastructure. It's a game changer for deploying devices like IP cameras and phones, making the network more streamlined and versatile. As evening approaches, the engineer reflects on the importance of quality of service QoS in traffic shaping. In the same way that cities might prioritize emergency vehicles or regulate traffic flow to prevent congestion, QoS and traffic shaping ensure critical network applications receive the bandwidth they need, and data flows remain smooth and efficient even during peak hours. Finally, as night falls, the network engineer considers the role of access control lists, ACLS, and address resolution protocols like ARP and RARP. These tools are the gatekeepers and directory services of Network City, determining who gets access to which resources and ensuring every device can find its way to the correct destination. In Network City, the job of a network engineer is never done. Each protocol and management task represents a piece of the intricate puzzle that keeps the digital metropolis thriving. From preventing traffic jams with STP to powering devices with PoE, every action they take ensures the city's data continues to flow efficiently, securely, and reliably day after day. It's a challenging but rewarding responsibility, knowing that with every configuration and every line of code, they're shaping the digital landscape of Network City.